rupees to access that swimming pool for 2 hours. You say, no, I don't want 1,000 rupees. I want 1,000, like Rohit coins, right? I allow you to use the swimming pool if you give me Rohit coins. So you have to go to the Bitcoin exchange or cryptocurrency exchange. These are instead of banks, you're going to online entities. So you can go there, you can deposit cash and buy Rohit coins, and using that coin, you can use the swimming pool. So the advantage of this utility coin is that a stake in all these regulations like SEC or SEC in the US coming down and on you and saying you're doing some scam, right? You're just selling worthless coins and stuff. So in case of utility, you're actually there's a utility involved. So this is a way workaround around these issues. Then there's speculative, that is like Bitcoin, INR, dollar. All these are in the sense they're not backed by anything. They just when you buy Bitcoin, you could effectively. This is a question a lot of people ask me, like, well, what are you buying when you buy Bitcoin? If you were to buy 10 Bitcoins, right, today, if you go on the market and buy 10 Bitcoins, I would say that you're paying the miners. So you're paying infrastructure for the miners to buy laptops or servers and mine your coins or validate your transaction. So in a way, I would say that you would never lose. I mean, like the price will never go to zero because there will always be there will always be miners at least who are mining transactions. They don't want the price to fall. So there's kind of a little bit of manipulation involved, but we'll get to that again. So you have speculative, that is, it's not backbending. Then finally you have asset back. Like you can say that rather than moving 10 physical gold bars from Hyderabad to Bangalore, I would just move the coin online. And if I move 10 Rohit coins or Sandeep coins, then I'm effectively moving 10 gold bars, right? So you're saying these coins are backed by gold. So this kind of is also a new concept. Again, there's something called as off-chain and on-chain. On-chain is everything is happening online. Off-chain is in the real world. So asset-backed currencies move on to the off-chain thing, where you have to get lawyers involved, or if somebody runs away with the gold bar and stuff. So you have to do regular auditing by Deloitte, KPMG. These are auditing companies. They say that no, they do bookkeeping. They make sure that your records are fine and stuff. So that is again hard to implement asset-backed currencies. But latest research is you have something called stable coins. That is the currency does not fluctuate. This is an active field of research. So they're backed by shares, so they're backed by bonds. These are all financial instruments. We can get into that. But in generally speaking, asset-backed currencies, you can say this. If you buy 10 coins of this, it's equivalent to the buying a real estate site of 60/40 site, buying a house, right? You can tokenize anything. You can tokenize the house. You can tokenize IOU thing or a book. Buying this is equivalent to having access to 10 books or something, right? So these are the types of coins you can generate. So it's a new world and a new field. Governments all over the world are still trying to frame laws, including in India, as you would know if you're following the news. So the image on the right is just saying that somebody just came onto the market and said, if you buy 10 coins, then 10 banana coins, then its value is equal to 1 kg of bananas in the international market, right? So tomorrow you could just launch a banana coin saying, you want something real, you want something tangible, something that you can value. Like Bitcoin has no value behind it. That's what people say. So rather than that, you can say the price will not crash because it's always pegged to this 1 kg price of bananas, right? It's always fixed price. It's a fixed price entity. So similarly, you have Tether in terms of cryptocurrencies. It is always fixed to price of $1 US. So the advantage of using Tether is that now anybody can send money between US and India. Remittances comes into picture. You want to take a loan for your masters and go there, and you want to send back money home, then you can send Tether. So again, there are regulations involved. Both the Indian government and the US government would want to make sure that you're not doing anything illegal. So for that, you have in banks you have KYCs, right? So I mean, like they take your Aadhaar card and say that this is the person. They're tying. It's equivalent to saying every anonymous email ID that you have that you're using to communicate has an ID attached to it. So similarly, every Bitcoin address or wallet address has an ID attached to it. So this is one way of preventing crime, so to speak. So these things come into picture. So this is again all introduction. Regarding technical questions, yeah, I'll get to that. Again, Rohit was asking, how does the miner know what get awareness of the system, right? So there were two concepts, two kinds of consensus protocols in place, right? Two main kinds. So there's proof of work and proof of stake. Proof of work is, let's say Rohit wants to earn a reward for validating the transaction between me and Akshay, right? So to earn that reward, he has to do some work. He has to guess the hash value hash is, you guys are computer science students and electronics, so hash is nothing but you have a page of text, you can compress it to a fixed length of string size, right, of only 10 letters, right? So the hash size is only 10. So hashing is a direct map of any length of text to a fixed length of text, right? So in case of miners in proof of work, they have to guess a particular hash value. We'll come to that in more this thing. And the person guesses it first, he wins the block reward. Currently, the block reward is 12.5 bitcoins per block, right? So if you tomorrow, if you want to, if your Facebook or Google can set up thousands of servers, all you have to do is just do computational calculations and try to get the correct hash value. And once you get the correct hash value, you win the reward. So the more computation power you have, the more rewards you're getting. So this is a big problem because it's no longer a democracy. The person with more laptops is getting to vote more, and he's getting to, put a politician over there on the seat, right, based on his computational power. So that is proof of work. That is a little bit of a flaw. It's centralized. The whole point of blockchain was to decentralize things. Like, you don't want a central entity where the government comes and puts them behind bars, like Facebook or Uber or something. They can this thing. In case of decentralized things, there's I read it somewhere that it's equivalent to a 10-headed snake. If you cut off all the 10 heads of the snake, there'll still be somebody somewhere in the world who will open his laptop and start mining. An anonymous guy. He'll start validating transactions, and now you don't know who that guy is, where he is, and stuff. Right? So that's the reason it's decentralized. Anybody can take part. Anybody can join the network, start validating transactions, and anybody can leave. So this is proof of work shown to the left. Complementary to that, in exact contrast to that, you have proof of stake, where the amount of money that you hold gives you power over validating transactions and getting rewards for validating transactions, right? So the more money you have, the more possibility of you, winning rewards. And the reason this works is because if you're holding $10 billion of, say, some coin, any Ethereum, right? Ethereum is a cryptocurrency, the second largest cryptocurrency in the market by volume. So if you're holding 10 million Ethereum, it's in your best interest that the price does not crash. So you want to maintain the infrastructure that people are not attacking the network, and only the right people get to validate transactions. You're not double spending transactions. That is, if my balance is only $10 and I'm sending $10 both to Akshay and Rohit, then I'm double spending it. It's called a double spend attack. So this is proof of stake. We'll see the differences and contrasts. So this is Whitelake, who was the lead developer of Ethereum, and I just got a screen grab from one of his talks. So he's basically saying that most of the proof of work consensus, right, where you're validating transactions, is happening in China. Bitmain is the biggest, largest company. So they own most of the infrastructure. So they can do a 51% attack. That is, if they own more than 51% of the computational power, they're getting 51% votes in a democracy. So they win the thing. They can do whatever they want with that thing, right? So again, there are two layers of protection for anything. And as long you have to own a private key in order to spend your coins in your wallet. There's a concept of a private key and a public key, which are, I hope you guys know a little bit of it, but if you don't know, you can stop me and we can discuss more at the end of the talk and stuff. So a wallet address is nothing but a hash of your public key, and private and public are just kind of, you have RSA cryptography where they're just prime numbers, they're complementary prime numbers and so on. And then you have elliptic curve cryptography where these are just numbers on the curve, and that's how they're generated. The private key is generated for every corresponding public key. Public key is everybody in the network is aware of. This is Akshay's public key. If he sends a message signed with his private key, anybody can verify that this message came from Akshay, right? So that is the private key, public key system. And digital signature is just signing messages with it's a regular signature kind of a thing with your message. I'm not going into the detail of how these are implemented. This is again all overall because this talk is about proof of stake consensus protocol in Ethereum. So right now this is real world research. It's happening. Ethereum is almost around. You see the market cap value, right? For the total number of coins that are there in the market, they're worth around 300 million or something. I have to check. But so there's a lot of money involved. Even if you have a single bug, then you risk losing that 300 million going to just people start selling the coin on the open market. They don't want to hold that coin anymore. It's like selling gold. All of a sudden, there's too much gold in the market and the price crashes, right? So Ethereum price could crash for the same reason. So now what they are doing is Whiteley, right? They are trying to transition from earlier proof of work consensus to a proof of stake. So again, I missed a crucial slide here. So the way this thing works is blockchain is nothing but you could call it a step over distributed database. First, you have a single database, right? You have a single file on a single laptop or a server, so that's a single file. You make copies of it, backup copies of it, and you have a consensus protocol to maintain, make sure that all of the copies are having real-time updation, right? So that is distributed database, right? So this again distributed database is, let's say Facebook is maintaining it, it's maintaining 10 backup copies of their servers. So it's maintained by a single entity, a central entity, so it's centralized. So if anybody else can come and maintain the database for a fee and walk out anytime they want, so then it becomes decentralized, and that is what is Bitcoin about, Bitcoin blockchain all about. So somebody is maintaining a log of your transactions anonymously, they're getting paid for it, and as long as the set of anonymous group of people have 51% ownership of your servers, you're safe, right? Nobody's attacking you. So this the only way to attack is a lot of these miners colluding with each other and attacking the thing. So this has happened in the past, in the sense some one company gaining 51% access to the computational power, then people just leave the network. They just randomly leave, and they no longer support the coin. So the coin price crashes. So now the person who's doing this 51% attack has no incentive to hold the coin. So he's losing his own worth. If he's holding 10 coins and if he's attacking his own coin, then it doesn't make sense. So that's the point. So that was proof of work. Then we spoke of proof of stake. So one of the problems is right now that's happening in Bitcoin is you need a lot of electricity. Only people who have electricity are sitting and mining it. They're getting free electricity, cheap electricity near waterfalls or whatever. So, and they have a little bit of these mining machines that just do all they do is all 24 hours they're just calculating hash values, right? So Bitmain has the largest this thing as of now, and you have pools of miners and stuff, and pool and so on. So again, all these mining equipment that is being generated is just generated by one company, Bitmain. It's almost worth, I think they made $4 billion of profit or revenue in a single year. So that is the control they have on the suppliers market, hardware supplier market. So it's by a single manufacturer. So that is a concern. Like someday this network might be attacked and so on. So like they can start messing up with your database, which is holding all your balances and transactions, right? So right now, again in blockchain, you have two main things. It's called main chain and the testnet. You have a test, a place where you can test your code, so testnet. So right now they've implemented something called as Casper. It's named after a ghost. So it's a proof of stake protocol. It's already there in testnet. So you guys can run a node. You can just download the database and try to start validating transactions on Casper. So it's they took around 2 years to do this. It's not yet been implemented, transitioned to the mainnet. We'll see why they have not done it, because there's a lot of complications involved. It's not easy, you want to make sure that your money doesn't go to zero, the balance doesn't go to zero. So it's again, from a computer science perspective, all you're doing is you're writing protocols, you're writing consensus mechanisms. So you could, in fact, do a PhD, spend 5 years saying my protocol takes lesser electricity to come to a consensus, come to a conclusion, and this guy is the winner of the voting system that we did. She should be the PM or whatever. So the prime minister and so on. So the more efficient your protocol is, right? It could be proof of work or proof of stake. You're a leader in the market, and a lot of people will. It's like a snowball network effect. If 10 people are going to buy it and the demand increases, 100 more people will rush to buy it, and the price goes from $100 to $10,000, right? That's how these markets work. So Casper is based on proof of stake. And it provides finality over block revisions. We'll get to that point. What I mean by that, it just means that once 10 people come to a consensus, 10 validators come to a consensus, you can say that you can no longer change the data that has been done. So blockchain is immutable in that sense. Nobody can delete a record and so on. So that is, you always have a record of, entire record of, like if you own Bitcoins, 10 Bitcoins right now, you can go do a chain analysis and track all the way from where it came, right? All the 10 people who are involved in moving the transaction. That you can't do that with cash. So that's called fungibility. There are again coins which are trying to implement fungibility, that is anonymous eCash and stuff, done by Zcash and Monero. So that's a different talk altogether. It's a very exciting field in that sense. If you're trying to implement some fungibility, getting privacy, it's always a debate between privacy and governments trying to make sure you're not doing something illegal, right? So that always is there. So here I mentioned some proof of work coins, which cryptocurrencies that maintain proof of work thing. Bitcoin, Ethereum, Litecoin, Monero, these are all working proof of work. You have hybrid which try to, if you own a certain number of coins and you lock those coins for a certain period, it's called staking. So that is proof of stake. And now you have the right to vote and say this is the right block, right? So if you do some mistakes, then we'll see how we can penalize you and kick you out of the system if you're trying to attack a proof of work system. So we'll study that later on in the coming slides. So you have a combination of both, and you have only proof of stake coins like Cardano, Omisco, Quantum, Order. These are all multi-million-dollar cap coins, right? If you, yeah. Yes. No, fungibility is, there was a question regarding what is fungibility. Fungibility is just you not being able to trace where the coin came from, right? It's the coins move from one person's hand to another person's hand, and so it's 100% privacy. Like nobody knows the 100 rupee note that you're holding in your wallet, who held it before you, right? Of course, they say the serial numbers on the coins and all on the RBI note and stuff, so that we'll get into that later. But the assumption is that you can't track where the coin came from and where it went to, right? That kind of, only the buyer and the seller knows it. So that is anonymous currency. But in case of Bitcoin, it's safe. I would recommend you to go and buy it. I wouldn't say that. I won't say it online. I'm holding coins, so I can't. It's a disclaimer. So I made a lot of money. I bought ETH when it was just $12, and now it's around $600 to $400. So you can say. Let's give random numbers. If I had put in 5 lakhs, I'm now sitting on 25 lakhs or something. I have to pay tax and all that. So we'll get to that point. But this is how, my friend started his own coin while doing his PhD, and that's how I got involved in this space. That is the take-home message I want you guys to take home. There's a lot of potential here. A lot of banks all over the world are trying to implement their own coins. In Japan, you have, I think, one of the leading banks launching their own coin or something. So these things are happening all the time. This is a technical talk. So in case of previous implementation proof of work, I'll quickly skip to them. Bitcoin uses proof of work, this thing. So the whole point is blockchain is nothing but the single database set of transactions. So if there are 10 miners, then each of them are, and they're maintaining a full node, each of them are maintaining a copy of the database. So now how does this database copy get updated, right? 10 miners. Among those 10 miners, one guy gets to win a lottery, that is he guesses a correct hash, and he gets to add blocks on top of the previous set of blocks. So let's say this is a block. There are, say, 1,000. It's 1 MB size. You can squeeze in some maybe 100 transactions. So all the 10 miners in the network have agreed that this is a valid data, right? And next another block is added. Another block is added. So now if I want to send money to Akshay, right? So there's a transaction involved, right? So that transaction goes into a block. And that block is mined by a miner. That is, a miner guesses the hash value and he says, okay, I won the lottery scheme and now I'm going to add this transaction to the database. So there's always a chain of data, blocks that is being involved. So there's always a fight to put blocks on the longest chain, right? If you're putting blocks on the and side chains in other chains, you're not going to make any. You will not get any block rewards. You'll not get any money for mining coins. So the incentive here, inherent incentive, is always to maintain a canonical chain. That is the main chain. So here, if my transaction is here, right? If I send some money, If I send some money to Akshay in this particular block, right, in the first leftmost block, when some other set of miners add a block onto this, it's equivalent to saying they've verified the previous transactions and they've given a confirmation. So if you add one more block, then it's second confirmation. So you have, as you add on more blocks, you're getting more confirmations. So if you're using Bitcoin, if you're holding cryptocurrency, right, if you're using ZPay and all, they always look for 6 confirmations, minimum 6 confirmations. That is, at least 6 blocks are there. So if I want to, if some person wants to attack this network and change the transaction between me and Akshay, he'll have to guess the hash value of this. He'll have to spend that much of electricity. He'll have to have like, say, a football field size of servers to get that hash and then reverse this transaction. then he has to reverse the next block. So he has to reverse 3 different blocks and then get to that point and then change it. And then he has to add 3 more blocks, make it the longer block, the largest, the block with the chain with the longest length, and then he wins, right? So for that you need a lot of computational power. So which means you need 51% computational power. Right now it's not possible because there's so much of electricity that is being used, right, to do this computation. It's almost equal to the electricity that Iceland uses. An entire country is Iceland. So that much of electricity is going into this to secure the network. So me sitting here in my office just opening a laptop and trying to attack this, it's not going to work. I mean, when Bitcoin was released in 2008, 10 years, almost 10 years ago, you could mine transactions on your laptop. Now it's not sufficient. If you run your, if you try to mine and guess a lottery and win a block, you don't do it for 10 days. You get point. You would. I mean, yeah, it's not possible actually. Right now, it's not possible. You need a lot of computation to get the block and get it. So that is the problem. So I have mined myself in my previous trans. I used to mine coins and I've made money, and it's like free money, right? If electricity bill is just 10,000 rupees and you're making 40,000 worth of bitcoins coming into your wallet, so it's good mining thing. So the way this database is structured is shown here. I think I'm spending too much on Bitcoin proof of work. We have to switch to Casper. So these are just 10 transactions. They are hashed, hash 0, hash 1, and then the previous 2 transactions are again hashed, and they are hashed again to get a root hash. That hash is put in the block header. And then the entire block header is hashed and linked to the next block. So every block is linked to its previous block in that sense. Then there's something called as a nonce, which is where the lottery scheme comes in. Like it's a random number between 1 to 256 or whatever. So you can assume I don't know the exact number, but so you would have to guess this number. You use 0, 1, 2, 3. You keep incrementing, keep guessing, keep hashing, and if it matches your a certain number, then you win the lottery. So there's a lot of more technical detail involved, but the general point is you're just guessing a random number and for this nonce, and once it matches certain difficulty value and so on, then you win the thing. So that is proof of work. The whole point is you're doing computations, right? And this computation is useless. It's wasted. If you say that I'm going to sequence DNA, if I sequence 10 DNA strands, and so I've proved that I've done work of sequencing 10 DNA strands, that can't be used here because that work is useful. It's not useless. You have to do some useless work to do proof of work, right? I mean, you have to prove that I'm wasting energy to maintain the security of this network. Right? If you have questions, please feel free to interrupt. Again, if I'm going too slow, do let me know and I'll skip to the interesting bits. So now proof of stake is, let's throw away all the electricity. Let's not waste so much electricity. Let's just hold coins in a wallet, and if I'm holding $10 million, it's in my best interest that I don't, mess up with the network, right? So I'm going to validate myself. I'm holding so much coins. I'm going to validate the transactions. I'll do it for free. I'll even do it for free, so that my coins worth does not go down. So that is proof of stake. So you're staking coins. You're just depositing some coin. In case of Ethereum, they are going to transfer from proof to proof of stake. So you could start tomorrow. Like if you deposit 32 Ethereum, you can stake. Need a minimum of 32 Ethereum. That is around $15,000 or something. You can still pool in the money from 10 people, and so once you do that, you will get at least I think 5% interest per annum. So all you're doing is just sitting, and the code does the validation and stuff. The mechanism is that every miner has to make sure the balance is right. He's able to spend. He has that money that he's spending, and he's got the right block reward and so on. So it's just peer-to-peer network. 10 miners, one miner wins the thing, he broadcasts that he's won the thing, and all the others agree. They add on to they increase the blockchain by 1 block, and then they again start mining the next blocks, right? So in proof of stake 2, what they do is they hash the previous block's hash value, they hash the timestamp, that is at this particular time this block was created, and they also have a factor called coinage. It's just the number of days last time they mined a coin by number of days in a year, and then they hash that thing, and a new block is created. So these are 3 blocks that are shown over here. So it's very simple and straightforward. You remove that concept of proof of work and so on. There was this, because it was so straightforward, it was easy to attack as well. There was this thing called nothing at stake problem a while ago when people were actively discussing in all these Reddit forums and so on, where developers working. The concept is very simple. The simplest of proof of stake is just this, that I'm holding $10 million in my wallet, so I have no incentive to attack the network, so your coin is safe. The problem with this is there are two blockchains, right? One is, you can see left and right. So I could sit here, I have $10 million in a wallet and I want to validate both the chains. Like I'm going to say, I'm sending $10, I have only $10, let's say I have only $10, right? I'm sending $10 to Akshay on this chain and I'm sending $10 to Rohit on this chain. So you have these two complementary chains and I'm spending just $10 twice, right? That is the nothing at stake problem. Like you're not losing any money, you're just making money, you're spending infinite amount of money. So here nothing was deposited. No, you didn't have to deposit any money to take part in the system. You just have to say, people just assume if you're owning coins, then it's in your best interest to not screw up the system. So that was the nothing at stake problem. So later on now, you have an iteration over that, an improvement over that is, you have to first, if you want to take part in Ethereum's proof of stake consensus protocol, you have to buy Ethereum 32 ETH, lock it up in a contract, and it's there sitting there. And so it's like a deposit. It's a rent. When you pay rent, you pay upfront deposit, right? So it's stuck. Your money is stuck there, so you can't withdraw it anytime you want. So this solves this proof of stake problem, right? If you try to validate transactions on both the chains, then you'll be penalized. Your stake will be reduced to zero, from $10 to just $0, right? So this is like a voting mechanism. Other miners see that this guy is trying to scam the thing, scheme the system, so they'll include that transaction saying the previous person, the other miner is making a mistake, or he's doing it deliberately, and they'll reduce your stake. So that is proof of stake. Again, the entire talk is just 1 hour, and it will be very superficial. If you want to dig into it, I would. All these images and all are got from a specific paper, the Casper protocol. It's peer reviewed. You can go through that thing. The whole point is this should make it easier for you to just hit the road running and start writing the code, and you can. In fact, this is all open source code. It's if you want to take part, you can send an email to the Ethereum Foundation, and you can start downloading the code from GitHub and playing around with it, forking it, or launch your own coin copy of that. So once Bitcoin was launched, a lot of people just forked it and started they started with Litecoin. Instead of creating a block every 10 minutes, I'll create it every 2 minutes, so on. So Litecoin was born. So thousands of coins are there. You can start your coin tomorrow, and as long as people are willing to pay for it and hold the coin, you're good to go, right? So in terms of proof of stake attack, one was nothing at stake. Other attack problem is it's called selfish mining. In proof of work, at least you had to have Facebook had to have like a football field size number of servers to do the computation, right? Here you don't need any computation, so you can just deposit. You can lock in say $1,000 in a stake. You can stake your coins, and then you can try to validate two different chains at the same time. So sorry, in terms of sorry, I didn't say this right. In terms of mining, what happens is that if you already know that I have more computational power than the guy sitting across the table, so I'll mine 10 blocks, right? I'll not release it to the open network. I'll just mine 10 blocks at once, just keep them hidden. Nobody knows about it. And at once I release 10 blocks. And the problem with that is that at this stage, I'm buying a coin, and let's say I go to a bank and cash out some money, right? I put a transaction saying I want to withdraw $10,000, Bank of America. And here I've received the cash. So once I receive the cash, in a separate chain, since I'm able to do 10 blocks faster than you, right? I can include a conflicting transaction and announce that, no, this chain is not valid anymore. This is my chain because I had 10 blocks sitting correctly and I'm doing it right. So this is called selfish mining. That is, if you're able to mine faster than the other people in the thing, or if you're hiding a block and releasing 2 blocks at once, this is a problem. So again, I've not explained it clearly, but you guys can go and read it. Won't be able to cover everything. The whole point is, if you can predict how fast the other guy is mining, then you can game the system, right? So coming to this, the prediction is called globally predictable thing. So you have these coins, that is Cardano, and all these are again recently these coins, and people have been like going crazy trying to get access to these coins, right? So they can infinite number of blocks you can predict definitely. You know that this block is going to take 10 minutes to mine. So I know for the next 20 blocks, it's going to take 10 to 20 minutes to mine, right? So you already know beforehand how much it's going to take to mine this. So because you know the pace of the network, you can game the system. You can release a block at this time and then release 10 blocks at that time and so on. So Peercoin, again, all these three are Tezos. All these are recently launched coins. They raise millions and millions of dollars just by releasing these coins in the market. This is just all you can predict how if what is the pace of adding blocks to this chain, right? One way to avoid that is you have something called as one locally. This person, I think he's from Algorand. It's another coin. He's from the developer is from Stanford. He's a professor, and he raised $4 million to come up with this coin. And what he does is it's one locally predictable. I mean, I won't go into this, but the point is it's no longer the number of blocks that defines the longest chain. It's something else. It's the number of signatures or something, right? We'll see that in case of Ethereum also. It's the number of checkpoints. I only have 15 minutes left. So the point is, if you were to sign every block, right, then you can't predict. I can't predict that Akshay will be the next miner who will win the thing, and his signature is one that is going to come. So if you're including digital signatures at every block, then it becomes a 1D predictable, right? Only one block, only the next block I can predict. The next block, I don't know who's the miner and what is the space, because I don't know whose signature is getting included. So I mean, that is the point. It's just about predictability. So you can read it up later on. So these are the kind of selfish mining attack, nothing at stake and so on. So coming finally to Casper, it's very simple concept. The point is, you don't want to, I hope you guys understood proof of work. It's just, this is a chain of blocks. Each block is like 10 transactions. So I want to add more transactions. I add a block. I win a lottery and add a block. Every time I win a lottery, I'm making $12.5 bitcoins, 12.5 bitcoins. And the market value, people are willing to pay. If I go sell 12.5 bitcoins, people are willing to pay me whatever worth. Each bitcoin is around $6,000. So they're willing to pay me $6,000 just for one bitcoin that I've mined, right? So that is the thing. So that is how this thing is maintained right now. And the only way to attack is a 51% attack. So in case of Casper, it's just it's only responsible for finalizing blocks that once here you're actually including voting system. 10 validators, instead of miners, you have validators now. 10 people with 10 laptops say we'll put to vote and say this is the final block. Right now you can no longer change it. So it protects against conflicting checkpoints. So the problem with blockchain is that it's always about the longest chain. So sometimes what happens in Bitcoin, there was something called as the user activated soft fork. So they just fork the coin. Split the chain into two chains, right? And said, no, I no longer care. A bunch of miners said, I no longer care about this main chain. I'm going to. It's like this is always a fear. People say that if all the miners in China say that we'll go one way, and all the miners in US say we want to go another way, right? Then the chain splits into two. If you have 10 miners, they're splitting into 4 miners versus 6 miners, right? That's what happened in Bitcoin and Bitcoin Cash. There was a hard fork. There was also a hard fork in Ethereum and Ethereum Classic. So these are all coins in the market to trade in, right? So a chain split is one of the possibilities. So in Casper, they say that it won't happen because you have people who are finalizing the blocks, right? We'll get to that. We'll get to what a checkpoint is and so on. So on top of the existing, before blockchain came into the scene, you had Byzantine fault-tolerant algorithms that were used for maintaining consistency in distributed database, right? So on top of the existing distributed database, Byzantine fault-tolerant algorithms, you have accountability. That is, you know who's adding this transaction, who's trying to attack the system. You have dynamic set of validators. That is, in a room you have 10, like all the people who are attending this talk, right? If all of us become validators, 2 of them want to leave the network, right? And any 3 more people can join anytime. So it's a dynamic set. Anybody can come, anybody can vote and stuff. So how are you going to maintain this consensus? So we'll look into that. And then there are defenses against attacks. So we'll get to what are the possible attacks and stuff. And the transitioning they were planning initially was from. Yeah, you can ask me a question. Could you just type your question? There was a question actually, but I'll continue at the same time. Please type your question if you have any. I'll be able to see it in the chat. Yeah, I think there was a question. So yeah, but the point is, right now what they're trying to do is you already have proof of work in Ethereum. On top of that, they are overlaying Casper and finalizing thing. But eventually they'll move to a full proof of stake. So it's a hybrid right now between proof of work and proof of stake. So it's if you have an existing system which is working fine, on top of that you can add this protocol. That's the whole point, right? So again, we are talking about distributed databases. What is Byzantine fault tolerance? P is practical Byzantine fault tolerance. So the point here is in terms of Byzantine fault tolerance. Let's say there are let's say the total number of nodes are you have n nodes, right? 10 miners or 10 validators. So n is 10. So among 10, 3 are faulty, right? 3 want to attack the network, right? So 10 minus 3 is 7. So as long as you have, say 10 minus 1 is 9, 9 by 3 is 3. So a PBFT algorithm can tolerate up to 3 attackers, right? So in coming back to this, let's say you want 10 votes to finalize this block. So among that, 3 are attackers, right? So you need at least 7 votes to guarantee that system is safe. So among these 7 you don't know whether the votes are coming from the 3 votes that are coming, are they from faulty nodes or from real nodes? So again, from 7 you have to subtract 3 and you're left with only 4. So because within your 2/3 you're not able to decide the 1/3 is from right people or wrong people, you can leave them out. So you're left with only 1/3 votes, right? So on top of that 1/3 vote, even if you get one single extra vote, then you can say your system is safe. It's just a client is sending a request, I want to add some record to the database. So among 4 miners or validators, a leader is chosen. He takes the transaction and broadcasts to other people. So here you can see this 4. So only even if one node is faulty, you still have 2/3 majority and you're safe. So that's the point. So then they prepare and each of these nodes send to everyone else. The backup nodes send saying, yeah, I have received the message, and then they commit, and then they finally reply to the client saying, yeah, you can now go ahead and stuff. So even if this last node is faulty, right, you're still getting 2 votes, and you can say that at least one of them should be safe. The other attacks, like Sybil attacks, like you're saying, instead of saying I'm one node, I'm 10,000 nodes and stuff, that is a Sybil attack. But if you have digital signature, you can't sign on 10,000 once, so that is avoided. The one you'll only get rewarded if you're mining on the top of is taking on top of the largest chain, right? The left-hand chain is useless. The right-hand chain is where you're making money. That's the point. So there are some concepts. These are just terms. The height function is just shown here, right? Height 0, height 1, height 3, and height 6. That is what is being shown here. Every 100 block is called a check. Each checkpoint is every 100 block, right? Except for the first one, which is the genesis block. So you have something called as a supermajority link. It's just an ordered pair of checkpoints, A to B. So it's deposit weighted. Instead of 10 people in a room saying 10 validators, it's 10 coins in a room. If there are 10 coins, then I need 2/3 majority of 10 coins, 10 ETH coins. Each coin is a vote by itself, right? Every 100 block is a checkpoint. So instead of considering every single block, you consider every 100 block. Then you have concept of validated deposits. You have to deposit, ETH to validate transactions. You have rewards and penalties. The whole point is you don't want to have 3 blocks here, right? At this height, you can see 3 different blocks. They're all conflicting. You just want to have, at every height, you just want to have one block. So that is a blockchain, the main blockchain. So you can call 2 blocks as conflicting if, this chain is conflicting with this chain because they don't have a common descendant ancestor relationship. The ancestor for this is this block and the ancestor for this block is this block, right? So they don't have a common chain of ancestors. So they're conflicting. So the whole point of your consensus protocol is you shouldn't have conflicting blocks. That is all you need to ensure, and then you're on your way to making $1 million, right? So to speak. So if you have to maintain consistency, you have to maintain a stable system. So checkpoints is you say a block is justified if it has a child. You can say there's just 2 concepts called justified and finalized. You can see these 4 red blocks, right? So all the 4 are justified. That is, they always have a link to the root, so they are justified, and they are finalized in the sense as long as B2 has a child to it, it is finalized. So B2, B1, and R are all finalized, and basically in this diagram you have 4 justified blocks and 3 finalized blocks. This last one is not finalized because it doesn't have a child, but it's justified. That is, it has a link to the root, right? That's it. You have second finalized. But you have a source checkpoint, a block that is finalized, source block and target block. So source is always comes first. So it's an ordered set of blocks, and public key of validator is not there in the validator set. Even then, it is considered invalid, right? So vote is just height of the block. Height I just mentioned. It's just at what block height or checkpoint height. So this is height 1, height 2, height 3, and so on. So you just send height of source, height of target, height of the source block, the target block, and the public key of the validator, and also a signature. The whole thing is signed by the thing, and this is your vote. This is the condition for losing your deposit if you want to be a validator. It's just two conditions. At any given height, an individual validator, like tomorrow you want to just open your laptop and start making printing money from home, all you have to do is just validate transactions, and for that all you have to ensure is that you're not sending two conflicting votes. That is, you can send two votes such that source 1 target 1 and source 2 target 2 height 1 height target 2 height 2. You should make sure that you're not sending a validator must not publish two distinct votes for the same target height. It's simple. The next one is a validator must not vote within the span of its other votes. Otherwise, if you do that, then your deposit is flashed, right? As long as 2/3 majority is there, you're safe. And longest chain is just justified checkpoint thing. So these are two Casper commandments. Basically, at this point, the second one says you can't vote within the first vote. Like you send a vote from S1 to T1, within that link you can't send another. You'll see the attack, right? So any data, if you talk about distributed databases, even before blockchain came into the scene, the way distributed databases are assigned was you just need to ensure two properties. One is called accountable safety, that your system is safe. That is, at any given point of time, only one valid set of transactions exists. I mean, conflicting transactions don't exist. So you have accountable safety, and then you have liveness. Like at any given point of time, irrespective of the history, you can add more blocks onto that on top of that system, right? So you don't have to bother of the history. It's live. The network is always live and kicking and it's working. Just two rules. One is at a height, you should have only one block. And the second rule, I'm explaining that now. So that is within a set of supermajority links, that is, you can see the red link, like R to B1 to B2 to B3 to B4. You shouldn't have another supermajority link that is A1 to A2 to A3, right? So this violates V2. So you can see this here. You have source 1 and target 1, right? Within that vote, you're also trying to send another vote which says source 2 and target 2. So this should not be done. So this is violating the protocol. So the only two ways to attack, you get kicked out of the system. You just basically your node drops out. So or your money is taken out from your wallet and given to the miner or other validators, distributed among them. So that is what is happening. So here, if you follow those two rules, that's enough to say that your system is safe. Liveliness, again, it's also pretty ridiculous. It's very simple. It just says that if you have a link from A to B, and on top of that A to B, you have A dash, and on top of that A dash, you can keep adding blocks, right? So the system is always alive as long as you maintain those two. This is a lot of text, but the point is, if you maintain these two rules. All of the rules of, you can keep adding blocks onto the chain and it is always alive. Other things. Now, how do you maintain a dynamic set of validators? Like, say, purple guys always include a block and they walk out of the system. Then another set of green validators come. Like 10 people walk into the room, they give a vote of C and walk out, and 10 other people come into the room, they give a vote of C dash, right? So now you have conflicts because there was no record of who was the validator signing this thing. So, right. So to avoid this attack, if you want to leave the network, you can't leave immediately. You have to wait for 4 months. You want to withdraw some money. You want to withdraw your deposited stake of coins. You have to wait 4 months. You don't violate any commitment. You don't get any slash. You are staking 32 ETH to become a part of this value. You have another thing called long range attack. That is, if you have a withdrawal period, what happens is you can say, okay, I'm leaving the room. I was a part of this 10 validator node, and I just want to leave the thing. I'm done with making money, and I want to leave. So after you leave, you can still set a conflicting vote and send it, right? So that is what is being shown here. Attacker submits a withdrawal request at this point, and at the same time, after withdrawal, attacker fabricates a conflicting chain, right? So this is called a long range attack. As long as there is possible liveness, you won't have this kind of a problem. Then inactivity leak is like what happens is some guy like me, I just want to hey, even I want to validate. I enter the room of 10 validators, but I just sit idle. I don't do anything. I'm just, I'm trying to damage the network by being inactive, and I'm reducing the security of the network by being inactive. So one way to prevent that is, the longer I sit inactive, the more money I lose, right? There's a validator A goes offline, and because if I go offline, I'll start leaking my deposit. If I've deposited 32 ETH, I start losing money. So that was the thing. And this is the last slide, guys. So it is just saying that if you want to build next generation consensus protocol, if you want to make your own coin and make money, then you can start just download the code and start doing your own consensus protocols. Like, it doesn't have to be every 10 blocks, or it doesn't have to be so much money that is included. You can have your own voting rules. There are things called delegated proof of work. I mean, there's tons of ways of doing it. Neo or Cardano, all these are coins, and they have their own consensus protocols. They're saying there's a proper voting mechanism in place. So you can send an email to Ethereum group and start coding. If they need Python engineers, they want P2P master. I bought a Bitcoin for 800, and then it crashed to 100. But luckily I didn't sell. I kept it, and now it's gone, like, I mean, it's exponential. So my point of this slide is that let's hope if you hold the coins, there's again another pump. It's called a pump and dump. People just drive up the price by, like thousands of people trying to buy the coin at the same time, and the price shoots up. And then thousands of people trying to, dump the coin, sell the coin at the same time, the price crashes. So this market cycle keeps going, and all you have to take this into consideration so that the network is safe. You're putting deposits, but if the deposit is worthless, then you have more incentive to attack and stuff. Again, in terms of careers, there are a lot of them. You can become an asset manager. You can manage coins. You can read the underlying protocol and say, no, this is good. There are a lot of developers who are working on this. There's active GitHub code being submitted every week. So this is a good coin, right? You being a graduate student, you have an advantage. And I mean, computer science guy or electronics guy compared to anybody, a retail investor or a noob investor, like, they don't know what is going on. They just see price going up and they buy it, right? So you can create your own coins. You can back those coins by a bar of gold, or you can, instead of, you have something called a smart contract. Smart contract is just that in the code it just says that I've rented out a car, not paying monthly payments. Automatically, the legal document is signed by the code, which will transfer the title from the car title from my name to Akshay's. So that is the beauty of smart contracts. You can have automated smart contracts peer-to-peer, and I actually hold the coins, so it is in my best interest to read what is going on in the code over there. Like, if they mess up, if there's a small bug and the chain splits into two, when there's a hard fork, I'm owning $10 on this chain, and because the chain splits, there was a fork split, and I started owning 10 Bitcoins as well as Bitcoin Cash. So I got free money out of nowhere because the database got replicated. That's the whole point. How do you incentivize to make the networks safe? So that was my talk. I don't know if you guys are still around. Maybe you guys have already logged out or something. I hope at least Akshay is around. Hello.
I'm here.
Hi, man. So you can stop the recording now.